So when you talk about it, a little bit of this so that the word problems and the law of cosine stuff makes sense to you, and so that anytime that's not the only reason, but when it comes up and other times you know how to draw it and figure out where your angles are and whatnot, okay? So this is going on page 100 when we're done. And I wrote these notes and then I realized I needed to go in there and fix something. I'm not real happy with the end product here. I tried to not make it too wordy, but it's not really worded the best it could be. In addition to that, these two things that I want to talk about first, it's hard not to use the word that I give you right here when I'm talking about that. So we're actually going to fill in this word first. The direction that we are going to talk about with how we draw these angles is called bearing. Okay, so make sure you're putting this in the right blank. Okay, the bearing of a ship, a plane, something like that. So he has a bearing of whatever, however many degrees or whatever. Probably something that you may have heard before, or I'm quite sure you've heard before in a movie or on the news. You just may not even have realized it or thought about it. But to my knowledge, not anything that you've actually learned what it is and how to use it. So, and then it's represented by this capital Greek letter. What letter is that? Beta. Good. So this is the capital beta. So we're going to talk about bearing, and there's two different ways that you can talk about bearing, which means there's two different ways that it's measured or drawn, in our case, to draw the pictures. So in navigation, direction is measured clockwise from true north. So there's a difference between true north and magnetic north. I don't know what it is and I can't explain it to you, but there's a difference. Does anybody know the difference? It's something to do with the actual measurements and then the, I don't know, a compass and the magnets. Ask Alexa. Yeah, maybe we can ask Alexa. But it doesn't really matter because it's whatever you would draw as north. So, but it's clockwise from true north when additional north, south, east, and west info is not given. So if it just says you have like a bearing of 123 degrees. There's no north, south, east, west attached to that, just that's the bearing, then we're measuring that from true north. And this is what I mean by that. So you can draw what kind of looks like an X and Y axis, but it's what we're going to do north, south, east, and west. If we were going to plot this angle and on the coordinate plane, then we would start here at 0 because this would be our positive x-axis, right? But we're not because it said bearing. So if I did it from the positive x-axis, that my 123 ends me up in quadrant 2. But a bearing of 123, we start from true north and we go clockwise. So this is 90 and then I got to go about 30 more. So a bearing of 123 degrees would be right here. Okay. So we have to know how to draw that stuff correctly to be able to get everything in the right places to be able to get the angles we need for our pictures and whatnot, okay? We good with that? Any questions? All right, so then sometimes there's additional information added to that, which means you handle it a little bit differently. So direction is measured either clockwise or counterclockwise. When the info is given, and by when the info is given is the extra north, south, east, west stuff. So if I said we have a bearing of south 62 degrees east, okay? A bearing, that's how you would read that, a bearing of south 62 degrees east. This is actually very simple. It's easier than the other way, and it makes sense. You just have to have at least been shown it once. So here's my north, south, east, west, and this is what this means. Since it says my bearing is south 62 degrees east, I start from directly south, and then I go 62 degrees to the east, and this will be my position right there. That right there is 62 degrees. Okay. So the direction in which you go just depends on whatever the north, south, east, and west is that's given to you. Okay, everybody okay with that? Of course, you have to know where north, south, east, and west is and how to label them correctly. How did y'all learn how to put them on there correctly? Never ever smoke weed. I haven't heard that one. But never eat slimy worms, or I learned never eat soggy waffles. But whatever you got to do to get them in the right spots. Never ever smoke weed. I like that one. That's a good one. Okay. All right, so this is in contrast to a standard position angle, which we call theta. So I'm just putting that in there again so you have the terminology in there. Standard position are the angles that we've been drawing from 0 on the positive x-axis. So which is measured counterclockwise from the positive x-axis when the angle is positive. Okay. So that's basically stuff you already knew. So I'm going to give you two other terms because this all comes back up when we start talking about vectors, and there'll be a few more things we add to this. These two terms probably aren't going to come up now, but it's what's used to talk about the bearing. So it says the direction that a vessel is pointed. So if I'm pointed in this direction and I'm heading straight to those dividers right there, I'm heading right towards them because that is my heading. That's why that term is used. Like I'm headed that way, or I'm heading. That's my heading. That's my direction. But if I'm like in a rowboat doing that and it's windy outside, I might be aiming for that, but I might be being pulled this way, right? Or like when you're at the beach and you think you're staying in the same spot, and then you look up and you know where you started was like way over there because the water carried you down. So if this is my heading, I'm aiming for that and I'm rowing my little heart out, but it's pushing me this way, right? So the actual direction, which is affected by wind, current, and whatever, is called the course. So you're in a perfect world, the heading and the course are the same thing, right? But that's not the way it always works. So just a couple of terms that come up. But main thing right now is knowing how to draw and understand the bearing. Okay, we good? All right, so let's finish our notes from Friday. So get those. The 100th day of school. All right, does anybody not have their stuff from Friday? We all got it? It's yellow. Okay. So, it says 2 ships leave a port at 8 a.m. Ship A sails with a bearing of north 68 degrees east. So in order for me to draw that, I need to have my north there, right? So there's my north. It sails at a bearing of north 68 degrees east. So I end up over here. And this is ship A. And this is 68 degrees. So you got to get your angles put in the right spots or the measurements aren't going to end up right. Then ship B has a bearing of south 35 degrees east. So start from directly south and then go 35 degrees east would end up somewhere right about there. That's B, and this is 35 degrees right here. Okay? Everybody okay with that so far? And then it says how far apart are they at 2 p.m. So I'm going to put an X there. That's how far apart they are. Then it also tells me that ship A was traveling 17 miles per hour and B was 12 miles per hour. So is the 17 and the 12, are they the lengths of the sides? No, because those are speeds. So how do I figure out the lengths of the sides? Okay, I have got to figure out how many hours went by, and then once I figure that out, I do what? Multiply. Okay, so when it's time and you're trying to figure out how many hours, the safest way to do it is to count on your fingers, okay? Otherwise, some of y'all are going to subtract weird and wrong with time. And you don't start with 8, right? Because at 8, the time is 0. But at 9, that's 1 hour, right? So it's 9, 10, 11, 12, 1, 2. That's 6 hours. So yes, I can just multiply. And I'm not saying that what I'm about to write you absolutely have to do here, but when things get more complicated, or if you have fractional numbers, or you're not sure if you were supposed to multiply or what you were supposed to do, I want you to remember that you can take that 17 miles per hour, and that means that's 17 miles for every 1 hour. And then you know it's been 6 hours, so you want to know how many miles it is. It's a very simple proportion, and you've been doing proportions forever. And then when you do that, you just cross multiply. Well, in this case, when I do that, I multiply those two and divide by 1, so I'm just multiplying. And that's all that's happening. And you probably know that for here anyway and wouldn't have gotten confused. But on any rate or anything, remember, you can always tie it back to a proportion, and it simplifies it if you get confused. Okay, so what is 17 times 6? 102. And what is 6 times 12? 72. Okay, so I'm looking for x. I have this side and I have this side, right? And so I need an angle in my triangle, which I don't have any. Is there one I can figure out? Yes, I can figure this angle out by doing what? That would work. I mean, I could draw that in there. I could subtract them both from 90 and then add that together. Or all three together have to give me what? 180. 180. So I can add these two together, subtract from 180? Yes. Yes, and what does that give me? A number. 77 degrees. Good. Okay, so eventually you are going to have to decide whether or not you're supposed to use the law of sines or the law of cosines. This is a law of cosines assignment, so that's what you're using. But you have to think about, like if you were thinking, oh, I'm going to use the law of sines. Well, if you have two side lengths and one angle, the law of sines is a proportion, so it's going to give you another angle. That's not what you're looking for, right? And so I don't need another angle. I want this side length, and so this is a side angle side situation, and that tells you it's the law of cosines. When you're looking for a side length, the side length is what goes outside by itself, and it's squared. That's equal to the other two side lengths squared and added together, minus 2 times those two multiplied together, times the cosine of the angle across from the side you're looking for, which is 77. So once you get all that laid out in there, then the rest is just typing it in the calculator and making sure that you're actually finding x in the end. So I'll give you a minute to get that done. All right, who's willing to give me a number? What you got? And that would be miles. Do y'all agree with that? That is the correct answer, so make sure you can get that answer. And if you're not getting that answer, let me know. If you have a 5-digit number, then most likely you typed in everything on the right-hand side of the equal sign and stopped, and all that gives you is x squared. You don't care about x squared. You want x, so make sure you're taking the square root. Okay, that's been the biggest issue today. Okay. Anybody having issues typing things in, not finding their mistakes? Okay. All right. Okay. So then, number 8. It says, Bruno and Eliana are figure skaters. Starting from the same location, Bruno skates 29 feet at a bearing of south 55 degrees 9 minutes west. Eliana skates 18 feet at a bearing of south 16 degrees 51 minutes east. How far is Bruno now from Eliana? So the way in which the angles were given to you, what are we going to have to do? Convert. So I'm going to have to draw it. So this 55 degrees 9 minutes, I need it in decimal form, and I need the 16 degrees 51 minutes in decimal form as well. So here, what do I do with this 9 minutes? Divided by 60. Good. So this is going to give me 55.15. And then this 51 I have to divide by 60 as well. So it'll give me 16.15. 85. Okay, so now I have it in decimal form. I'd much rather label that on my picture than the degrees minutes seconds version of that. Okay, so let's go back and read this question then. So we're starting at the same location. Bruno skates 29 feet at a bearing of, so let me get my, here's a bearing of south 59 degrees west, or 55.9, or 55.15 degrees west. So this is 55.15, and he went 29 feet. She skates 18 feet at a bearing of 16 degrees 51 minutes east, so she's going this way, and that's 16.85, and that's 18 feet. And I want to know how far apart they are. Now my picture is not to scale like at all, and it doesn't matter. You got to have it big enough that you can write numbers in places, so as long as the things are in the right place, it's fine if it doesn't look right. All right, everybody good so far? Understand where everything came from? Because we got to be able to label them to be able to do anything else. Okay, so I have, once again, two sides, and I'm looking for a third. I have these two pieces here, but I need this whole angle. What's that whole angle? 72. When you add them together, you get 72 degrees. So once again, we are using the law of cosines because it's side angle side. So go ahead and I'll let you get that one substituted in and see if we can get it figured out without me writing it down for you first. Why do you look confused? Do you just not read my handwriting? It's this up here, this angle and this angle. All right, anybody want to give me a number? .024 feet. Y'all agree with that? Yes. Okay, good. That's the right answer. So make sure that you can get it. Don't just, if you didn't do it, if you didn't get that, then make sure you can get it. Even if you just keep getting the wrong thing every time, then when we're done, I'll come and see if I can help you figure out what you're doing. But okay, we all good? Okay. So a helicopter spots 2 landing pads below. The straight line distances from the helicopter to the pads is 14 miles to landing pad A, 8 miles to landing pad B. All right, so here's my helicopter. Just start with that part. Straight line distance, that means the actual distance between here and landing pad A is 14 miles. And from the helicopter to landing pad B is 8 miles. And they are 20 miles apart. Okay. So I've got all 3 side lengths, which means I'm going to be looking for an angle measure. And it says find the angle of depression from the helicopter to landing pad B. So is that angle inside of my triangle? No, because to get the angle of depression, you got to look straight ahead, then you look down. So it's this angle right here. Now, is that angle the same as an angle in my triangle? Yes. Which angle? Angle B. Because these are what type of angles?
Oh. Inside alternate?
Okay, very close, yes.
Interior.
Alternate interior. You've got parallel lines cut by a transversal. Those are alternate. You had the right idea. The alternate interior angles, and they're congruent. Okay. So really, if I just find angle B, that's my answer. Like that's not the actual angle they're looking for, but it has the same measure. Angle B I can find. Okay, because with the law of cosines, if you have a side-side-side situation, you can find an angle measure. So since I'm looking for angle B, the side across from it is the one that's outside by itself. So this is going to be 14 squared equals and the other two in either order. 8 squared plus 20 squared minus 2 times 8 times 20 times the cosine of angle B. Now you can rewrite the law of cosines, the formula, in a form where the angle is outside by itself, but then you just have more formulas. If you can write it down like this and not make ridiculous elementary school errors, then you're fine. And by that I mean you cannot just square these and multiply these and combine all of these numbers right here. That is a big fat no, okay? Because this right here has a cosine of B attached to it, right? So don't, think about that when you're doing that. So I'm going to give you a second. Let's see if you can get that figured out, because there were some of those on Friday. You just didn't have to draw the pictures. Give you a second to see if you can get it. There's different ways to type it in. You don't have to do it exactly like I did it the other day. All right, now somebody that doesn't normally give me an answer, be brave. It's okay to be wrong. Last period I had somebody that did not want to tell me, and that was on that first one. He said, I don't want to tell you my answer because I'm probably wrong, because he just never wants to tell me his answer. He said, well, because I have a 5-digit number, so I know it's wrong. I said, well, that helps me. I know why you have a 5-digit number, because you didn't take the square root. If he hadn't said that to me, I wouldn't have been able to tell him why he was wrong, right? So if you're wrong, it's good that I know so I can help you figure out why. Somebody, anybody? Go ahead. 33.1, thank you. 33.123 degrees, and that is the right answer. Okay.
No, I erased it because it was really wrong.
Well, if it's really, then you probably didn't take the cosine inverse. Think about that. Okay. Once you get that, once you get a number, you have to take the cosine inverse at the end, right? And see, if she hadn't said that and we hadn't had the conversation, I wouldn't have been able to figure out your mistakes. Okay? So if you had an answer and you feel like it was wrong, now just take the cosine inverse of the answer, and that's probably what you're going to have. Okay? We good?
Wait, keep it up there.
Okay. All right. If you had, anybody have any major issues that we need to discuss? Grab the homework real quick because I want to talk about the last one. If you're still having issues with this number, once we're done, I'll come look and see if I can help you if you can't get it figured out. Okay, so on number 9, the word problems use bearing, so that's why we had to talk about it, which I do think it's valuable that you at least have heard it and know how to draw that. Number 11, however, I feel like you have to have more bearing knowledge and more geographic latitude, longitude knowledge than you should have to spend time on in pre-cal, really. So here's the thing, is that you may not be 100% confident in which angle you're looking for in number 11. If you draw it, label it, read through it, do what you think makes sense, and as long as you find an angle correctly and you could explain to me like why you chose that angle based on what it says, even if it's not the correct angle, then I'm not going to count it wrong. Does that make sense to you? I'm more concerned that you could actually find an angle, not that you are a bearing expert at this point. Hopefully you understand bearing well enough from this, and I think on 9 and 10 the bearing knowledge you have is enough, and that's really all you need at this point unless you are going to do some other crazy type of navigation stuff. So I'm wishing that I had changed number 11 now, because it's not really just the wording. You have to have some more knowledge of how to do this stuff than y'all have, and that's okay. So just think about what you know and what you think might make sense Find one of the angles, make sure you explained which one it was, and then it'll be fine, okay? You may have a different answer than your neighbor, and that's okay too. I don't want you to stress out over it, okay? We good? All right, one last thing, and I know this is going to shock you, but there's a mistake on the review. If you look at number 22, which is really on the front because the numbers don't make sense, it says if the base of the ladder is 17 feet from the base of the ladder, well, that makes no sense. If the base of the ladder is 17 feet from the base of the building, that's what it should say.